Hey y'all, this is the Unit 8 review video. Again, Unit 8 is all about oblique triangles, which just means that none of the angles of that triangle are 90 degrees. And again, this is the law of cosines, law of sines, all those fun formulas. You will get formulas on the test, and you should have use of a calculator. So please make sure you have access to one of those. And let's talk a little bit briefly about some general triangle knowledge you should have before you even get into those law of sines and cosines. The first thing is if you're given a triangle, and a lot of times they're going to call these things like triangle ABC, triangle XYZ, triangle CAT, doesn't matter. Whenever you're labeling these, make sure you just pick a spot and you label each of your angles with the uppercase letter that corresponds. And then the sides that are opposite those angles are going to be the lowercase angles that match. So we're going to have uppercase A is across from lowercase a. And again, side lengths are going to be denoted by lowercase letters. B will be across from B, and C will be across from C. And again, that's true for if I had triangle ABC, if I had triangle XYZ, if I have triangle whatever, there's going to be 3 separate letters, and you'll just label your triangle accordingly. Remember, whenever you're looking at a triangle, any type of triangle, all the angles are going to add up to be 180 degrees. That helps a lot when you're given 2 angles and you're looking for the third one. In order to find the perimeter of a triangle, you're going to add all the sides together. So in this case, I would add up side A plus side B plus side C. I know that one seems silly, but it comes in handy for the area. And finally, please make sure that your calculator is in degrees. If you're using a TI-84, if you have an updated operating system, you might even see at the top it says radian. Again, if you're not sure, go to mode, and you need to change your mode into degrees. So you hit the mode button, you go down, highlight degrees, press enter, and now you're in the correct mode. We don't use radians when we're given sides of triangles and stuff like that. It's just weird to use. So let's get started with the Unit 8 knowledge. So again, we're going to use the law of cosines when we're given some triangles that are not right triangles. So those oblique triangles. So the first thing is this is the law of cosines. It's written out all of these different ways. You only really need to know one of them, though, because if you notice here, the angle that you're given, you also put the side that corresponds to it on the other side. So if I had angle A, I'd have that side across from it all by itself over there. If I had B, B, C, C. Okay, and this works for any set of letters. So the side that's opposite the angle that you know or the angle that you want to know is going to go across and all by itself over there. Okay, you're going to use these formulas when you're given enough information to use them, basically. And when that's going to occur is when you have 3 sides. So you have a side, side, side triangle, so you know all 3 of the sides. Or if you have a side angle side triangle, and that's when you have 2 of the sides and you know the angle in between those 2 sides. I don't know why I put 2 angles. It's fine. Okay, so again, you're going to have like this little thing. You can't have the angle that's over here. That's not going to help me because I need to know something about that angle that's across from that side. Okay, so again, basically when you're going to use the law of cosines is when you have 3 different letters, whether it's an uppercase A and a lowercase b and c, or if you have all 3 of the sides. Okay, so let's go through a couple examples. The first one is this guy. And again, the easiest thing I always do on these is I just draw my picture. And I know you're going to be like, oh, but I know what to do for this. It's easier to orient yourself and realize what you have if you have a picture drawn. So if I label this picture, I know this side, I know this side, and I know this angle. So immediately I can see I'm dealing with a side angle side triangle. I have 2 sides and the angle in between. So I'm going to use the law of cosines. And on this one, I'm looking for the length of side C, which is nice. I don't have to do anything crazy here. And so I'm just going to set up my formula the correct way. Again, if I know the angle or the angle that I want to know, that's the side that gets to go by itself in this formula. And then everything else just kind of falls into place. So I'm going to have the other 2 sides squared. Hey, look, it looks like the Pythagorean theorem. Hint, hint. Okay, then I'm going to put this little extra side, the 2, and then those 2 sides, and then the cosine of C, which in this case is 32. And now I can go use my calculator. Okay, again, make sure everything goes where it's supposed to go, that you've used the correct side lengths in there. But then all you got to do, type into your calculator, times 5 times, 8. And then again, make sure you're in degrees whenever you're typing in something in degrees. Okay, so I got this. Now, please be careful. This is 21.156, blah, 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 blah. But that is equal to c squared. Okay, you can do a reality check for yourself at this point. 21 doesn't really fit in with these two sides, especially knowing that this is a little bit smaller of an angle. So I should probably have something in between, or maybe even less than. And if you notice, oh, look, this is actually c squared. So I do have to take the square root of both sides at this point. And yes, I could have typed this in under the square root to start. That would have been fine. But if you need to take the square root of your answer, again, it's the second squared sign. And it didn't tell me where to round here, so I'm just going to round to the nearest tenth. And that does make a lot more sense in regards to the problem. Again, do some reality checks for yourself. Make sure that big angles are across from big sides, that your sides are kind of matching up where they are. Okay, we still can use logic on these triangles. The second type of triangle that you may be faced with are the side-side-side triangles on the law of cosines. And these take a little bit more work just because you do have to do a couple extra steps. However, you just have to be careful while you're doing them. So if I draw my triangle and label it out, I'm looking for the measure of angle Z. Okay, so the side that is across from that angle that I want is going to be the one that goes by itself. And again, this is a side-side-side, so I'm going to use the law of cosines. And so since Z is the one that I want, I'm going to have 4 squared go alone. Then make sure you don't use 4 again, basically, is what it's going to boil down to. Your 4 is all alone over there. You're going to now use the other two sides that you have, 3 and 6. And again, these two match that as well. And then the cosine of Z. I don't know what that is. This is like a variable at this point. I need to solve this entire equation for that variable. Pretend it's an X if it makes you feel better. So the first things that you should do are your subtraction. It's what SADMEP, the opposite of PEMDAS, where you're going to subtract these things, and then you're going to end up dividing by whatever's in front. So I'm going to end up subtracting this 3 squared from both sides to get rid of it, and this 6 squared from both sides to get rid of it. And again, you can just do that on your calculator. Okay, 4 squared minus 3 squared minus 6 squared. Okay, and that's going to get me negative 29. And then I'm going to multiply all of these things together. Be careful, this is a negative 2. So negative 2 times 3 is 6, times 6 is 36. So I'm left with negative 36, and I probably should have done that on my calculator just to make sure, but we're good. So now, again, at this point, you want this to be all by itself. These things are being multiplied, so I'm going to divide both sides by this negative 36. When I divide a negative by a negative, I get a positive. And this is equal to the cosine of Z. So if I wanted to get whatever the measure of angle Z is, again, I can't divide by a cosine. That's just not an operation that I can do because this is an actual operation happening. So in order to get rid of this cosine, I need to do the inverse cosine of both sides. And in order to get that on my calculator, I'm going to press second. So I'm going to do second cosine 29, maybe 29 over 36. And again, if I'm in degrees, it should give me an angle measure. So if I round this to, let's say, 1 decimal place, I would have that the measure of angle Z is equal to 36.3 degrees. So again, that one took me a couple extra steps. Really, the thing you need to remember is that whatever side is opposite the angle that you know or that you want to know is the one that goes by itself. Then in order to isolate the cosine of the angle that you want, subtract some stuff, then divide. Be careful of what your SIGNs are, if it's positive or negative, and then do the second cosine of both sides in order to find the angle measure. Okay, so that's the law of cosines. The law of sines can be a little bit more straightforward when you're going through and solving, but when you're using this, again, you can either put your sine of A on the top, or you can just put your side A, but your A should match up, your B should match up, your C should match up. And when you're doing these, you really are only going to use half of, well, 2/3 of this formula at once. You're only going to have one proportion set up. We're just saying we could have that third proportion also stay true. So in order to use this formula, just looking at it, you're probably going to need either multiple angles or multiple sides, okay? So in this case, we're going to use it if I have 2 angles, which angle, side is an example of having 2 angles. So if I had an angle, and then a side. I don't know why I wrote an S there. That's fine. Okay. Or angle, side, angle. So if I have two angles and then the side that's in between those two angles. That was an awful picture. It's fine. The last time you're going to use the law of sines is the side-side angle case, but this is a special one. I'm going to talk about it more in the next section with the ambiguous case, but you do use the law of sines if you have the side-side angle. And again, you can use this in any way. You can put your sines on the top or you can put your sides on the top. So if I'm given this information, PQR, I'm going to draw my picture. This is triangle PQR. I know side P, I know angle Q, and I know angle R. So again, this picture right here is an angle side angle, which tells me I can use the law of sines. And if you tried to use the law of cosines on this, you'd see you'd have a problem because you need at least two sides in order to do anything on the law of cosines, whereas the law of sines, pretty straightforward. I just need two of these angles. Okay, so when I set this up, I'm going to be looking for side R. So I'm just going to put that on the top of my proportion. So if I'm looking for side R, underneath goes angle R, the sine of angle R. And then, so that's R. I'm going to use the other piece of information that I know. So I do know side P, but I don't know what the angle P is. Luckily, this one's pretty easy to find. All I have to do is know that all the angles in a triangle add up to 180. So I'm going to take 180 minus 87, 51 minus 87. I guess it doesn't matter which order I did it in. And that's going to give me, I don't know, 42. There you go. Okay, so now I'm going to do the sine of 42. Now all I'm going to do here is cross multiply and solve for R. So in this case, again, when you cross multiply, your equal sign still stays there. So I'm going to have R times the sine of 42 equals 17 times the sine of 87. These pieces right here, the sine of 87, the sine of 42, they're just numbers. They're ugly numbers, but they're just numbers. So in order to isolate the R, to get the R by itself, I'm going to divide both sides by the sine of 42. And I'm going to type this into my calculator. Now, when I type it into the calculator, please be careful that you've closed the parentheses appropriately. So I'm going to have 17 times the sine of 87. Here's where you got to close your parenthesis. Then divide by the sine of 42. If you use the second or alpha y equals in order to make a fraction, you don't have to worry about it quite as much. But here it'll start doing some funky stuff arithmetically, whatever. So make sure you close your parentheses. So at this case, and now at this point, I have that the side R should be 25.4 if I round to one decimal. And again, I do myself a little reality check. Well, that makes sense. I have across from a bigger angle, I have a bigger side. Cool, great. Okay, again, the law of sines is pretty straightforward as long as you know when to use it. Now, biggest issue with the law of sines is my favorite, the ambiguous case. Okay, on this ambiguous case, you're going to have, you're only going to use it when you have a special case of the law of sines, which is the side-side angle. Okay, and what's going to happen here is if you remember back in geometry when you're proving triangle congruences, this one made a problem because you could make two separate triangles if all you were given were the angle and two sides. So if you're looking at your picture, you have an angle and then a side and a side. This is the problem case. When you're looking at these, there are only ever going to be 0, 1, or 2 solutions. You're never going to have more than that. So sometimes your triangles are going to be normal. They'll just have one answer for it. Sometimes you're going to get an error in the calculator. You'll have no answers, or sometimes there are 2 answers. And in order to find that, to make sure how many solutions there are, you're going to find the first missing angle. So whichever one you're looking for, in this case, I'd probably be looking for angle B. Once you find that missing angle, you're going to take 180 and subtract that angle and then add to the given angle. So if whatever one they gave you in the problem, so in this case would be 20 degrees, and then you see, is this a real triangle? Is this the real life? Which means basically, is that less than 180? If it's not less than 180, you got one answer, you're good. Okay. If it's more, then I got to find both. So let's look on this first example. It's giving me this information. So let's draw a picture, make sure I have to use the ambiguous case. I do. It's sad. This is angle AB. Oh, we'll just call it C. Okay. So I know that this side is 6, this side is 10, and this angle is 20. So again, this is that angle side case where I'm going to have an issue. So I'm going to use the signs, but this is the like, oh my God, I need to check for the ambiguous, okay? Because it is that side angle. So when I set this up, again, just set up with whatever you know in this case. So because I know side B, I'm going to be looking for angle B, even though they told me I want to find side C. Okay, I have to kind of go through some extra steps here. So I'm going to set up what I know. I know that I have the sine of A over A, and then I'm given this side B. So I'm going to be looking for the sine of B. Okay, I'm going to cross multiply this and get a sine of B. Ooh. Okay, and so when I do that cross multiplication, I'm going to have 10 times the sine of 20, close my parentheses, divide by 6. Okay, and that's going to give me a decimal. So I know, oops, I almost wrote in the highlighter. I know that the sine of B is equal to this 0.57 business. Okay, in order to get that by itself, to find that angle measure, I'm going to do the inverse sine of both sides. And so I get that angle B, second sine, I'm going to go copy paste my answer, is 34.75-ish. Okay, so the measure of angle B is equal to 34.8. We'll just make this easy. Okay, this is the point where you need to check and see, is there another solution? Okay, because if there is another solution, I'm going to have to solve this process one more time in order to find both or all of the answers for this. So in order to check here, I'm going to take 180 minus 34.8. Because remember, when I'm trying to find an inverse sine, I can find one in quadrant 1. There's positive inverse sines in quadrant 1, but there's also some in quadrant 2. So technically, because I could have an angle that's bigger than 90 degrees in this triangle, I'm looking to see, is this second angle right here an actual triangle? So if I do 180 minus 34.8, which I'm actually going to do to make sure I can subtract. Subtracting is a very difficult art. Okay, I get 145.2. Well, maybe. Okay, and then I'm going to look and see, add it to what was given. So my given triangle or my given angle here was 20 degrees. So is 145.2 plus 20 less than 180 degrees? Is there space? Is there wiggle room for a third angle here? Well, this would be 165.2. That is in fact less. So this has two solutions. Okay, and this was how I checked to see if there were two solutions. So in this case, the angle of measure B could be this measure or it could be this measure. So in order to solve my triangle, I have to take both of those into account. So if I'm again looking for side C, I'm going to have to find two separate answers here. Okay, so now that I have that information, wow, that was a lot of stuff just for the first piece. Now I'm going to be able to find the measure of angle C, which is going to help me find side C. And again, in order to find that, I'm just going to take 180, the whole angle, triangle angles, minus my angle A, minus my angle B. So I'm going to start with the 34.8. So that's my first angle there, 125.2. Then my second angle, I'm going to erase this 34.8. 134, what? And I'm going to use that second one that I could have found. So this angle is going to be considerably smaller. So my two choices here are 125.2 or 14.8. And now I can set up my proportion one last time in order to find my angle C. So again, use what you know. The 20 and the 6 aren't going anywhere. So I'm going to have the sine of 20 over 6 equals to the sine of C over C. So in this case, I'd have the sine of 125.2 over C. And then I'll do it again with the 14.8. Okay, so if I cross multiply this, I'll have 6 times the sine of 125.2, parenthesis, divide by sine of 20. So I get that my first value for C would be 14.3 for that first case. And then for the second case, I'm going to set up the same exact proportion just with the second C value I found. So 14.8 divided by C. So same steps here. I'm just going to go in. I'm super lazy. And I'm going to go delete this. Sometimes I wonder if it would take me less time to just retype it, but whatever, it's fine. So the sine of that second thing, and then I get 4.5-ish. Okay, so again, whenever you're looking at these and they ask you to find this length of side C, if it is ambiguous, you have to check and see if there is that second solution. Okay, here's another example of this ambiguous case. And if you notice here, you only have two different letters. That kind of tells you that you're going to be stuck with an ambiguous. If this is triangle ABC, I have A, B, and then the angle A. So I'm going to set this thing up again, same way. Because this is the side-side angle case, this is the law of sines, but again, it's the asterisk law of sines. You gotta check and see if there are multiple solutions. Okay, so I'm going to set this up. I'm going to have the sine of 126 over 5, the sine of the angle over its side, corresponding side. Then I'm going to have the sine of B over B. They didn't even tell me what I'm solving for on this. I wonder if that's a hint that maybe there's no answer here. Or maybe they want me to solve the triangle. I don't know. I'm going to cross multiply and solve this for the sine of B. So I'll have 7 times the sine of 126 divided by 5. Again, make sure you've closed your parentheses correctly. And I get that the sine of B is equal to 1.13 . Okay. After I get that, I'm going to go ahead and try to second sign in order to find what the B value is. Oh no, an error. Huh. Okay, and again, so I went in here and I did the inverse sine of both sides, and my calculator spit out an error. Remember, whenever you're dealing with sine and cosine, you can only have a decimal answer. You can't get any bigger than 1. Think about your unit circle. It's only ever 1. That's the biggest number you can have for any of your x or y coordinates. If you get a number, sine of B equals bigger than 1, if it's 2 or 4 or whatever, if it's negative, it's still a problem. Okay, if this happens, go back and make sure you set your problem up correctly. Okay, I'm not saying that every answer is no solution, but if you've set everything up correctly and you still have an error or you still have a sign that's bigger than 1, this is just a no solution. There is no triangle that exists with these measurements. Okay, so that can happen. Remember, you can either have 0, 1, or 2 solutions. In this case, I didn't have any. So again, when you're looking at one of these law of sines, that's the ambiguous case. This is only 0, 1, or 2 solutions. Once you have found that missing angle, so like here, I was looking for that missing angle, you're going to go ahead and do 180 minus that angle to see if this new angle could actually be in a triangle. If it can't, then you only have one solution, and that happens. Okay, otherwise you'll have to use both of your new answers in order to find all of the solutions when you're solving your triangle. Okay, so again, on this one, I basically did solve the triangle. Here, I couldn't solve a triangle because there was no triangle possible. Alrighty, let's change gears a little bit and go into area. There are 2 formulas for area. This is the 2 that are written right here. Again, they have specific uses in specific cases. So first of all, this is the formula we called Heron's formula. You're going to use this when you know all 3 sides. Okay, in order to use this formula, you have to have a side triangle. And they've given you what each of the variables mean in this case. This semi-perimeter, remember, semi is half. So you're going to find the perimeter of the triangle. So you're going to add up all the sides and just divide it by 2. That's it. That's a semi-perimeter. And then you plug it all in this formula, area pops out. This formula right here, the area equals 1/2 AB sine C. It looks a lot more like the area equals 1/2 base times height. That's going to be when you have a side angle side triangle. So when you have a side and the angle, 2 sides and the angles that are in between it. Because again, there's 3 different letters here. If you have 3 different letters, you probably have a side or side angle side triangle. So if I look at these 2 cases, again, it is the most useful, and I need to see my formulas. I don't have these memorized. It's the most useful to draw a picture for yourself to see which case you have. So this would be triangle DEF. And I know angle D is 28. I know that side E is 8 and side F is 17. This is a side angle side triangle, which means I'm going to use the 1/2 times the two sides. And then be careful here. This is the sine of those. A lot of times I see sometimes we accidentally use the cosine. That's a problem. Okay. Don't use the cosine. This is the formula has a sine in it. So 0.5 times 17. And again, you can use 1/2. That's fine. I was just super lazy there. Make sure you're in degrees again. But then that's the area of this figure. Super straightforward. So now I know that the area is 31.9 units. So these are centimeters squared. Done. Okay, so again, this was a side angle side. I could use the more straightforward formula. If I see the second one, again, draw your picture. This looks like JKL. So I have this angle, or sorry, this side, and this side. So this is going to require me to use the more complicated formula, even though it's not awful. So the first thing that you're going to need to do is be able to find that semi-perimeter. Okay, we need to find the semi-perimeter, otherwise there's no way for me to use this formula. That S that's in there is going to cause some problems. So when I find the semi-perimeter, again, I'm going to add up all the sides and not divide by 3, but divide by 2. Be super careful when you're doing this. You have to divide by 2. It's half of the perimeter. So in this case, that's going to end up being 30 divided by 2 is 15. So now I can just plug that into that big formula. So the area is going to be the semi-perimeter times 15 minus one of the sides, the semi-perimeter minus another side, the semi-perimeter minus the other side, and then that's where your square root closes. Again, you're probably going to want to show me what formula you used as you were doing this, just to make sure, in case you type in something incorrectly into the calculator, that I knew what you were doing. You just accidentally typed in 11 instead of 12 or something like that. It happens to the best of us. Oh, look, I've already switched my numbers. It's fine. I just make sure I got all of them in there. -7. Okay, I got them all. Cool. And so now, great, awesome. The area of this particular triangle is 37.9. And it's inches squared. Cool. Okay, again, make sure you're showing what formula you're using. You figured out why you're using each of these formulas, but that's basically area in a nutshell. The last thing that you may see on one of these is one of these crazy figures where you're finding the area of the quadrilateral. Okay, really what's going to happen here is you need to divide this beautiful, gross looking four-sided figure into two triangles. Now, where we make our mistake usually is where do we actually divide? You always need to divide your figure where there's an angle across from it. If you divide from here to here, I don't know any information anymore. But if I divide from here to here, I now have a side angle side triangle, and I can use something to find this other guy. I'd only have two sides if I divided from the other two. So on this, again, always divide from the side across. So in this case, I'm going to be looking for 3 pieces of information. I'm going to need the area of this piece. I'm going to need the area of this piece. And I'm also going to have to actually find the length of that red line that I drew there in order to find the area of the second one. So the total area of this thing is going to be whatever I find for A1, and I'm going to add it to A2. Okay. Again, I'm going to need to find both of those areas first. So I'm going to go ahead and I'm going to find the area of 1 first because I have a lot more information on that one. So if I want to find the area of 1, this is a side angle side triangle. That's the easy formula. That's the one that I can just do 1/2 times the sides times the sine of the angle in between. Okay. Be careful when you're rounding on these because you never know when you're going to Sorry, I can't apparently talk and type at the same time. When you're rounding, be sure in your calculator you're keeping your unrounded answers for a bit so you can kind of see, make sure you're not rounding too soon. But the area of 1 we just found was 71.2. Okay, again, that was how I just used the normal formula, side angle side. Now I'm going to have this triangle up in the top. So this is the one that's always a little bit tougher. If I want to do anything here, I'm going to need an angle or I'm going to need a side. And unfortunately, finding an angle here is going to be a lot more tricky than just finding this side length. So the first thing I'm going to do is figure out what this side length is. And I can use the law of cosines in order to find it. Okay, so in order to find x, because I have a side angle side triangle, I'm going to use the law of cosines. So I'm going to have x squared is equal to the two other sides plugged into that formula. Again, the law of cosines. And then the cosine of 54. Be careful you're using the right law of cosine or using the cosine or sine or whatever here. So again, when I'm solving this, I can just put all of this underneath the square root. 8 squared minus 2 times 22 times 8. And then the cosine of 54. I hope I typed all that in right. Otherwise, we're going to have a problem. Okay, so I get that that side is about 18.5-ish. Again, I already took the square root, so I'm good at this point. Here, I'll just make it 18.47, just to make everyone feel better. Okay, now that I have this side, I have a side triangle, which means I can actually find the area of this second little highlighted triangle using that formula, the Heron's formula. So the first thing I'm going to need to do is find the semi-perimeter. So I'm going to have 16 plus 12 plus whatever side I just found. Divide that all by 2. Okay, so I'm going to have, 16 plus 12 plus 18.47 is what I called it. Cool. And I'm going to divide that entire thing by 2. This is kind of ugly. If you want, you can use the store feature on your calculator in order to just make it a letter. That way you don't have to type it all the time. But now I'm just going to use that. And again, I'm only using this top half of this quadrilateral. So in that formula, I'm going to have S times the S minus one of the sides, and then S minus another side, and then S minus that last side, 18.47. I know I used X. I should have put it in as S. It's fine. And so I get that that area is equal to 94.8. It's kind of funny. I got a little different answer because I rounded differently before. So I get that this whole area of A2 is equal to 94 point, no, let's just do 9. I'm fine. And now if I add those two areas together, that'll be the area of the whole thing. Cool, 166.1. Again, be careful with rounding, but there's going to be a tolerance on here. It'll be okay if you're a couple decimals off because I understand if you round it differently. But again, in order to find A1, I used my side angle side triangle formula. And then to find A2, I had to use Heron's formula because I had a side triangle, even though I had to find the last side. So this is really a conglomeration of all of the information we've gone over this unit. You have to figure out missing sides, you have to do the areas, and you have to add them together. So cool, that's area. The last thing we did were the application word problems, and really the whole point of these word problems is if you can draw the picture or maybe label whatever's given to you, you will be able to solve these. Okay, so read them carefully, but in the end, they're going to be pretty straightforward as far as what formulas you should be using, so on and so forth. So we have apparently 2 pilot questions, but a pilot of a transoceanic jet flying at an altitude 12,000 meters finds that a stationary ship is in the same vertical plane as the jet's course. He measures the ship's angle of depression to be 14 degrees. 2 minutes later, he finds it to be 43 degrees. How far did the jet fly in those 2 minutes? So we have a plane flying. I'm not even going to try to draw a plane. So this is where he started. And here's an ocean. And here's a boat. Oh my. Okay, well, yeah, that's a stationary ship. Okay, so I know that as this plane is flying, and I'm again going to have him go from left to right because that's normal for me. We know that the altitude, he's flying at a steady altitude of 12,000 meters. And he knows that the angle of depression at this first point is going to be 14 degrees. Be careful when you're drawing an angle of depression of this for this particular picture. Remember, if I look down and see this ship, well, there sort of is. The angle of depression is always going to be measured with a horizontal line. And this is going to be the angle of depression right here. So this is that 14 degrees. Okay, 2 minutes later, he's going to keep flying. So he's flying. 2 minutes later, we're going to call this 2 minutes, he finds that the same angle of depression is changed. And again, it's still going to be with this vertical line or this horizontal line. I don't know the difference between vertical and horizontal today. And this will be 43 degrees. Okay. And I want to know, how far did he go? So what is this distance in between these 2 points? So there's a couple of different ways to solve this. The first thing that I know is altitude is always with a right angle. Okay, altitude, like most of the time, like a tree or a mountain or whatever, it'll always have that right angle. So I can actually just use normal trig if I want to in order to find pieces of information out. The other thing I know here is that all of these angles should be 90-degree angles. So I know that right here, if I took 90 minus 14, I can get that this angle 76. And so then I could even find this little angle down here if I needed to. But what I'm looking for is I'm trying to get up into this top triangle, but I don't have any side links for that one yet. So I'm going to go ahead and I'm going to find this right here. I'm going to call it A since I already used X. Man, I already used it. So in order to find that, notice this is a normal right triangle. Okay, I just have a regular right triangle that has 12,000 on this side. Here's a right angle, here's 76, and I want to find the hypotenuse of that guy. So if I think about this, I'm given the adjacent leg, and I want to find the hypotenuse. So if I take the cosine of the angle, it's equal to adjacent over hypotenuse, which I don't know. I'm going to go ahead and solve that. Again, just cross multiply and solve. So that should give me the cosine of 76. Nope, 12,000 divided by the cosine of 76. I know how to do math. Divided by the cosine of 76. And I get that that distance is 49,602.8 meters. Okay, so I now know this distance right here. We just found it. I'm going to make it green. I'm going to make that not green. Let's make it red. That's what I'm looking for. Okay, so now I know this side. I know an angle. I could find the other side. The other nice thing that I know about this is I know that this is a straight angle. This is going to be that 180. So in order to find this guy, this could just be 137 degrees. So now I have an angle side angle, which I can just use the law of sines, which is what I would prefer to use at any given time. Okay, so if I know this angle, I can go ahead and find this angle. 180 minus 137 minus 14 is 29 degrees. So now I can set up my law of sines. I'm again looking for this one, this x, but I know everything about the 137 and the a. So if I set up sine of 137 over what I just found, that's a decimal point, equals this guy right here, so the sine of 29 over that x distance, and now I can just cross multiply and solve. So I would have, okay, that crazy number, oh cool, I can just use it right there, sine of 29, and then divide it by the sine of 137, and I get that number, which makes sense. And in this problem, like make sure it's not something too big, or you didn't get 4. He traveled 4 meters. But it's a plane. It's going pretty fast. That makes sense. Okay. And so that is how far that plane has flown in that 2 minutes. Okay. Again, the hardest part about that was the picture. Here's another one where they actually give you the picture, which is kind of nice. They say here, here's another pilot. We're just flying a lot of planes today. Finds it necessary to detour around a group of thunderstorms as shown. He turns the plane at an angle of 21 degrees to his original path. So right here is 21. Okay, so that angle is 21. He flies 100 kilometers. And then he rejoins the path 170 kilometers from where he left it. So that would mean that this is your 170 kilometers. So he's getting back to the path right here. Okay. How much further did he have to fly because of the detour? So this is what I'm going to be looking for part A, because that's the extra length that he actually had to go. And then at what angle did he rejoin his course would be this angle right here. So let's start with that first part. Again, if I look at what I'm given in blue here, blue, that's purple. I have side angle side triangle for part A. Side angle side means I should be using the law of cosines to find that missing side. And again, whichever side is opposite the angle that you know or that you want to know is going to be the one that goes by itself. So I'm going to set that up. Minus 2 times those two sides times the cosine of that angle. Throw that in your calculator. Again, make sure that you've taken the square root. You should get 84.6. And again, doing a reality check here, that makes sense. Okay, he did go slightly farther based on this, but it's still not, a million. And then the second thing they want to know is what is the angle that he's rejoining. So in order to rejoin this, we have an angle. We know these two sides if we want to use it. We could use the other side or use this other angle. But what I'm going to use here is, again, this is going to be angle, side angle. And so that's going to be the law of cosines. And I'm going to set this up as the sine of the thing that I don't know. I'm calling that part B. I guess I should make it a big B. Over the side that I do know equals the sine of 21. And I just found what this other side is that's opposite it. So 84.6. Do some cross multiplying and solving, and you should get 25.1 degrees. And again, that makes sense because this one's 21. This guy's a little bit bigger, so maybe it's going to be the angle will be bigger. Okay, so that's moral of the story. Draw the picture or label the picture with what you're given. Okay, there is a review with some more problems to solve, some more solving an entire triangle, some more multiple choice or some other word problems if you need those. But again, this unit is relatively straightforward as long as you remember what formulas you have and when to use those formulas.